equations, right? Method of solving an integral equation. So we'll see the introduction and basic definitions that we are going to use here, right? Introduction. An integral equation is an equation in which an unknown function appears under an integral sign. So the equation is in the integral type. So normally just a linear equation 2x plus 3y minus 4 equal to 0. Instead of 2x plus 3y minus 4, you are having integral. So integral f of x plus integral g of x, like that, which is equal to some k. This is the equation in integral. To find the unknown is nothing but the solution of the integral equation. So unknown function means you have to solve them and find the value of. Suppose x and y are unknown. We know 2, if you are having two equation 2x plus 3y plus 4 equal to 0 and x plus 2y equal to 0, then you can solve and find the value of x and y. X and y are unknown, like that, right? Such equations occurs widely in many areas of applied mathematics, physics and engineering. In physics, engineering, everything you are having the integral equations, right? There are in the higher level, right? So integral equation, the general integral equation is of the form hx plus h of s and g of s, which is equal to f of s plus lambda into integral over a k s comma t g of t dt. That is equation number 1, where the function f, h, k are known, right? That is given function, right? And g is unknown function. So we have to solve this equation to find the value of g, right? So which is to be determined. Lambda is a non-zero real or complex parameter, that is a number, complex or real number, and kst is called kernel of this integral equation. So the upper limit of the integral in one may be fixed or variable. That is why, so they have given lower limit a. Upper limit is sometimes a fixed number, so like b. So 1 to 2, 3 to 5, 4 to pi, right? Like that. Otherwise it is a variable, right? A to x, integral a to x. X is a variable. Integral a to y, y is a variable, like that, right? Note, the equation 1 is also called integral equation of third kind, right? Special type of integral equations. So first, Fredholm equation. So first we are going to see Fredholm equation. A Fredholm integral equation is an integral equation with constant integration limits. So there are fixed integral limits. If you are having an integral equation with both integral limits are available, so 1 to 2, 3 to 5, in that, right? In that integral equation, the limits are fixed or known constant, then the equation type is called Fredholm, right? For Fredholm equation, the upper limit of the integral in 1 is fixed. So Fredholm integral equation is of the form h of x, g of s, which is equal to f of s plus lambda into integral a to b, right? K s comma t g of t dt. There are two main types of Fredholm equation, right? They are first kind or first order Fredholm equation and second kind or second order Fredholm equation, right? So first kind or first order Fredholm equation. So in the first kind of Fredholm equation, the unknown function g appears only under the integral sign. For example, h of s, which is equal to f of s plus lambda into integral a to b k of s comma t g of t dt, right? So here see g of t, that unknown function g is only inside the integral, right? That is called first type. For the first Fredholm equation of first kind, put h of s is equal to 0 in 1. The Fredholm equation of first kind is given by f of s plus lambda into integral a to b k of s comma t g of t dt is equal to 0. That is equation number 2. Now we are going to see the second kind or second order Fredholm equation. So in the second kind of Fredholm equation, the unknown function g appears on both inside and outside the integral. See, for example, h of s is equal to g of s plus lambda into integral a to b k s comma t, k of s comma t, g of t dt. See, here g is inside the integral and outside the integral. So this is called the second type of Fredholm equation. So put h of s is equal to 1 in equation number 1. The Fredholm equation of second kind is given by g of s is equal to f of s plus lambda integral a to b k of s comma t g of t dt. That is equation number 3. Next, Fredholm homogeneous equation. So Fredholm homogeneous equation, integral equation, is a specific type of integral equation in which the terms representing the known function is identically 0. Right? For the Fredholm homogeneous equation, put f of s is equal to 0. This is the known function f of s, right, in 3. So the Fredholm homogeneous equation is given by g of s is equal to lambda into integral a to b k of s comma t g of t dt. See, there is no known function, right, in the right side, right. That is equation number 4. So next, Volterra equation. So Volterra integral equation is an integral equation in which the upper limits of the integral is a variable. So if you are having a variable upper limit in the integral, then it is called Volterra integral, right. For Volterra integral equation, the upper limit of the integral equation is in the form h of s g of s, which is equal to f of s plus lambda into integral a to x k of s comma t g of t dt, right. There are two main types of Volterra equation. So first kind or first order Volterra equation, or second kind or second order Volterra equation. So first order of Volterra equation is the unknown function is multiplied by a kernel within the integral. So the unknown function g is multiplied with kernel inside the integral. So for example, h of s is equal to f of s plus lambda into integral a to x, right. X is a variable. So here inside the integral you are having k of s of t into g of t. G is the unknown function, k s comma t is the kernel, right. So for the Volterra equation of first kind, put h of s is equal to 0 and take the upper limit as a variable x in 1. So equation number 1 becomes f of s is equal to lambda into integral a to x k of s of t g of t dt equal to 0. Next, second order Volterra equation. So in the second kind, it contains a term with the unknown function itself in the integrand. So for example, h of s is equal to g of s plus lambda into integral a to x k s comma t into g of t dt. See, outside the integral, see, g unknown function, inside the function is multiplied with the kernel, right. So for Volterra equation of second kind, put h of s is equal to 1 and upper limit of the integral is a variable x in equation number 1, the first equation, right. So g of s is equal to f of s plus lambda into integral a to x k s comma t g of t dt. Next, singular integral equation. A singular integral equation is an integral equation in which one or both limits of the integral is infinite. So the integral's kernel, the function inside the integral, become unbounded because infinite at one or more points with the integration interval, right. So for example, g of s is equal to f of s plus lambda. So lower limit minus infinite, upper limit plus infinite, k s comma t g of t dt, right. Thanks.